CNC machining it's incredible, right? The way it carves these complex parts from solid metal with like breathtaking precision. But behind all that digital craftsmanship, there are these hidden forces, these unseen enemies that can totally sabotage an entire operation, turning profit right into loss.
So what are they? That's what we're going to dive into today. We are pulling back the curtain on the 3 hidden enemies that, trust me, every modern machine shop is battling, whether they even know it or not. We're going to look at the problems, but more importantly, we're going to look at the data-driven solutions.
All right, first up, the big one. The most disruptive enemy, unplanned downtime. This is when your multi-million-dollar machine just stops. And look, this isn't some small hiccup. The data is pretty clear on this. Unexpected machine failures. They can slash a factory's production by up to 20%. Just think about that. Every single minute a machine isn't running, money is just vanishing.
Okay, enemy number 2, costly defects. We're talking about high-precision parts where even the tiniest error, a few microns off, can make the whole thing completely useless. This leads straight to scrap parts, wasted material, and in the worst-case scenario, you've got entire batches being rejected by a customer. It's this quiet but incredibly expensive drain on your resources.
And our third hidden enemy, well, it's hidden waste. I'm talking about that literal mountain of metal chips and sludge that every single shop produces. Most people just see it as a disposal cost, right? A liability. But what if I told you there's actual gold hidden in that bin?
So how do we fight back against these things? Let's start with enemy number 1, downtime. The key here isn't just about fixing machines faster. No. It's about predicting and preventing failures before they even happen. And our weapon of choice for that? It's data. Now, this is where it gets really interesting. Because machine failures, they aren't just random acts of chaos. Not at all. They actually follow very predictable patterns. As you can see right here, a massive 33% of all failures are mechanical, and another 25% are electrical. You add that up, that's almost 60% of all your problems right there. This tells us exactly where we need to focus our attention.
But we can get even more specific than that. The research shows that a staggering, and I mean staggering, 70% of all machine downtime is caused by just 3 specific things: spindle overheating, servo motor burnout, and improper tool loading. That's it. If we can solve just those 3 problems, we can eliminate the vast majority of our downtime. That's huge.
So how do we do that? Well, this is where a really powerful tool called FMEA comes in. FMEA. Think of it like a strategic playbook for fighting machine failures. Instead of just reacting when things break, FMEA lets engineers proactively identify potential failure points and then rank them based on how severe they are, how often they're likely to happen, and, crucially, how easily you can detect them.
What FMEA does is it calculates something called a risk priority number, or RPN, for each issue. And this chart, it lays it all out perfectly. You can see right away that spindle overheating and servo motor burnout, they have the highest RPN scores by a long shot. This isn't just a suggestion, it's a data-driven command telling maintenance teams, hey, fix these 2 problems first. They are your biggest risks, period.
Okay, so we've got a plan for downtime. Let's move on and tackle our next enemy, those costly defects. The big question is, how can we guarantee that every single part is absolutely perfect right from the very first one that comes off the line? Well, the answer is a super rigorous process called First Article Inspection, or FAI. You can think of it as the ultimate quality gatekeeper. Before you hit go on a massive production run of thousands of parts, you do this incredibly deep, comprehensive check on the very first ones. And for high-stakes industries like aerospace and medical, this isn't just a good idea, it's absolutely mandatory.
And the impact of doing this, it's huge. The data shows that a properly implemented FAI process can slash the number of returned batches by more than 60%. Think about that. That's a massive saving in time, money, and your company's reputation. It's all about catching a problem on part number 1, not finding out about it on part number 1,000. And FAI isn't just some quick check either. It's a very systematic 4-step process. It all starts with careful planning. Then you produce that first part, but you do it under real production conditions. After that, it's all about meticulous measurement of every single feature. And finally, you compile all that data into a formal report for review and approval. It's all about structure and discipline in action.
Now, for industries like aerospace, this whole process is standardized using what are called the AS9102 forms. Form 1, that's all about accountability. It clearly identifies the part and exactly who is responsible for it. Then you have Form 2. Think of that as the product's birth certificate. It verifies all the materials and special processes that were used. And finally, Form 3. This is the ultimate report card. It lists every single dimension, every tolerance, every feature from the blueprint, and compares it right against the measured results. With a system like this, there is simply nowhere for a defect to hide.
All right, we've tackled downtime, we've tackled defects. Now it's time for our third and final enemy, hidden waste. And honestly, this is where things get really interesting, because we're going to reframe this whole problem. We're not going to see it as a cost, but as a hidden revenue stream.
Just take a look at this number. $4 billion. That is the estimated value of recoverable materials. We're talking expensive coolants, metal scrap that is lost every single year in North America just because of inefficient waste handling. It is a mind-boggling amount of money that's literally just being thrown away. So the question is, how do you reclaim that value? Well, this is the answer. It's called briquetting. On the left, you see the before state, just a messy pile of loose, oily metal chips, which frankly has a really low scrap value. And on the right, you see the after, a dense, dry, and clean metal briquette. By using immense hydraulic pressure, a briquetting machine transforms that low-value waste into a high-value, super easy-to-recycle asset. It's an incredible transformation.
Let's just look at the data here. It really tells the story. If you just let gravity drain your chips, you might get back, maybe 20% of your coolant? If you use a centrifuge, you'll do better, maybe up to 50%. But briquetting, we are talking about recovering up to an incredible 98% of those expensive fluids so you can reuse them. And at the same time, it dramatically increases the value of the scrap metal itself. I mean, it is a total win-win.
So when you boil it all down, the path to next-generation efficiency really stands on three key pillars. First, you have to analyze your machine data proactively to prevent that costly downtime. Second, you inspect your first parts rigorously to completely eliminate defects. And third, you recycle your waste profitably to turn what was a cost into a brand new revenue stream.
So today we've unmasked three major hidden threats in manufacturing. But technology is always evolving. Factories are becoming more automated, more interconnected every day. And with that, new challenges are absolutely going to emerge. So my final question for you is this. As we get better and better at solving today's problems, what do you think will be manufacturing's next hidden threat?